In this video, we're going to be computing the standard deviation of a sample, also known as the sample standard deviation. We will be using the same data that was used in the video for computing the mean of a sample. So it's the 9, 3, 4, 3, 9, and 9. Now the formula for computing the sample standard deviation is we're going to use the square root, and then it's going to be the sum of each one of our observations, and then we subtract away the mean of our sample, or the sample mean, square it, and then we divide by n minus 1, where n in this particular case is 6, it's our sample size, and the x bar is 6.167. That was computed back in the video for finding the mean of a sample, or the sample mean. So to do this, we're going to compute it in pieces. We'll compute the sum portion first. So what that will end up being is we'll start with our first data value, which is a 9, and we'll subtract away that sample mean, the 6.167, and we square that. And then we add on another piece, which is going to be the 3, our next data value, minus the 6.167, and we'll square that. And then we add on another piece, which is the 4, our next data value, minus our sample mean, the 6.167, and we'll square that. And we'll repeat this for every single one of our data values. We'll take them, we'll subtract away our sample mean and square them. This is going to give us an inner portion of the sample standard deviation. This takes a little bit of time if you're going to do this by hand. But once we compute each one of these pieces, what we're going to find out is each one of these squares, or squared numbers, is going to be equal to, say, 8.0259. The next one will be equal to 10.03. The next one will be equal to 4.6959. The next one, since it has a 3 for the observation, is going to be the 10.03 again. And the last two will be the same as the first because they're using 9 as their observation, so it's the 8.0259. Then we would go ahead and add all these up, and we'll get something like 48.833. The next step in the formula would be to divide by 1 less than our sample size. So we'll take that 48.833 and we'll divide by 5. That's 1 less than our sample size. And so we'll find out that the sample standard deviation squared is 9.7666. And if we take the square root of that, we'll find out that S, our sample standard deviation, is equal to the square root of 9.76666, which equals roughly 3.125. And that would be our sample standard deviation. Now, as with computing the sample mean, the data can be entered either as a table or as a list. So if we made a frequency distribution table, we'd have an observations of 3, 4, and 9, and our frequencies, as before, would be 2 because there's 2 3s, then 1 because there's only a single 4 in the list, and then 3 because there's 3 9s. And then to compute our sample standard deviation, we could either make just a single list if we were going to use all the data that way, or if we were going to use the frequency distribution table, we could make a list 1 and a list 2. Now, to compute the sample standard deviation, or the standard deviation of your sample, simply go back to the video for computing the mean of a sample, follow all the same steps, and then you come down and look at the line that says S with the X next to it. That is going to be your sample standard deviation. So it's the exact same steps as computing the mean of a sample, or the sample mean. You just look at a different line. And it's going to be the line that says SX, not the next one down that has the sigma x. That's for doing the standard deviation of a probability distribution. We're looking at the SX line when we have data.